Hi, so today we are going to do something a little bit different. Instead of reviewing a board or a computer or something, we are going to try to learn about something, a topic that might sound complicated, but it's actually very simple. So I'm going to try to explain the concept in a very easy and repeatable way. So hopefully you will enjoy and hopefully you will learn something new today. So what we are going to do is basically I'm going to try to show you how you can analyze a device, an electronic device, a board that you might get your hands on. And let's say you don't know anything about the inner workings of the board and you want to understand how it works and extract secrets from it, maybe get some unauthorized access to it and extract firmware and do more, and basically how to analyze and extract secrets from a board that you don't know much about. In order to do that, there are various things that we are going to need. So we are going to access UART, JTAG and SPI stuff. So I'm going to show you the things that you're going to need if you want to do what I'm going to do in this video, and also I will show you a couple devices that I'm going to use for this video. I don't know if you can still buy them, they are very old. I used to use these devices to create some physically isolated network in order to do some analysis, but let me show you what I'm talking about. So device number one, and it's already graying and yellowing, so yeah, it's not looking great, but it works. Another device is this one, device number 2. Another one is this one, device number 3. And here we have something different, and device number 4, right? So if we want to cover what these are, I will show you. Basically, I'm not using these anymore. So this is the TP-Link TLWR841N, and this is the 300 megabit per second wireless router, right? So this is just something. This one is Cisco SE1500. So this one is, I don't think it's managed, unmanaged switch. And this one also even has the seal not broken. So I've never opened any of these, honestly. We are going to open them in front of camera, and I'm going to discover whatever is in there with you together. So we are going to see what we can do with a device that we don't know anything about. So we are going to do that. And finally, this one is Netgear N900. The model is WNCE4004. So a couple devices, right? And this one is a TP-Link unmanaged switch of some sort, I think. Yeah, desktop switch, gigabit, yeah. So this one is TLSG108 version 4.8. Yeah, so these devices I have never taken apart. I don't know anything about them, right? We are going to take these apart and look at the boards under microscope in front of camera, and then try to extract secrets from it. Try to get unauthorized access, maybe like shell access, if possible, and then try to read data from it, read the firmware, extract the firmware, and so on. So sit back, enjoy the show. I am going to take these all apart, open them up, and yeah, just enjoy the show. Let me try to open these up. Okay, so I opened them all up, right? So this is for this board, and this is for this one, right? And okay, and this one is here. So if you want to take a look at any board like this, right, the first thing that you might want to hunt for is actually something very similar to this. So as you can see here, these are like 4 pins, and there are no text, it doesn't say, but this is very, very similar to UART port, right? So UART actually stands for Universal Asynchronous Receiver and Transmitter, right? So you use that, actually you see that everywhere, and even in like a device like this, in an Arduino Uno, right? As you can see here, this is a TX and RX ports, and you just need another pin which is ground. And by connecting these, you should be able to establish a UART connection with some other device. Can be a laptop, can be a Raspberry Pi, doesn't matter. So UART is basically used to log text, and you can use it to send commands as well. You can send text and read the data back. So it's a protocol that is used to exchange data, let's just say. And as you can see, it usually does have like 5 or 3.3 and versions. And then there is a ground pin, TX pin, RX pin, and the 5 volt or 3.3 volt. So a VCC port, let's just say, right? So what you can do is you can connect 3 of these. You don't need to connect the power VCC. You can connect the ground, RX, and TX pins and hopefully establish a UART connection. And you will be able to send commands through your computer to that UART port. In order to do that, actually, you are going to need something like these cables, right? So this one I have marked it 5 volt. So this one is C23HM, right? But because it says EDHSL, so there are like 2 versions of this. This one is the 5 volt version, right? You have to be very careful, because if the UART is 3.3 and you connect it with a 5 volt, you might fry something. So there are also different versions. So this one has all the cables free. You can easily plug them into UART. If there are like pins, you can connect them easily. And there are also this version, right? So this one is also, you can see it in here. This one says, right, TTL232R 3 volt 3, right? 3.3 volt. So you can use any cable like this. There are a lot of variations. There are even USB dongle versions of it. It does have like pins sticking out of it. There are different cables, different ways to do that, but you just need an adapter like this. So you will be able to tap into these UART ports and connect them to your laptop, to your computer, which we are going to do. And you should be able to see those relatively quickly in most cases, right? Not all cases, most cases, but you might not see it. Or some boards just add some security measures in order to prevent just wiring it up and using it. They might have, some resistor on the way. They might have some traces not connected or something shorted. So you have to basically bypass those restrictions and then connect it with the UART in order to read and write to the UART port. Another thing that you always need to spot is chips like this. So we are going to take a look at this under microscope, but usually chips like this, I can't read it now. I need to look at it under microscope. There's another one here. I don't know which is which, but we are going to take a look at it under microscope. And the chips like this are usually, you have to read the label on it and Google it, and you have to find the flash chip, and then you will be able to use a tool called SPI Flash, or you can use as programmers and read and even write to these chips. And usually these flash chips usually contain firmware, and sometimes it just contains the configuration data. So you have to read to understand and check what is in it. In order to do that, I use it in the previous video. If you haven't watched it, when I was checking the Chinese motherboard, right? You can use something like this. This one is XGECU Pro model T48, doesn't matter. There are so many different variations and versions of chip readers. You can use these to read whatever is in there. So we are going to take a look at that. And then same thing in this board, right? We can take a look at this one. This one is a lot simpler than that. As far as I remember, yeah, this one does not have Wi-Fi capability. So it's just like an unmanaged switch. So you shouldn't expect a lot from this. We will try, and I already see the 2 possible flash memories, or maybe 3. I can't see it anything yet. I have to check it on the microscope. And then this one, yeah, so I already see something like this. Hopefully you can see it on the camera. You see these ones, the pins that are sticking out, and they are 4. So they might be the UART ports, might be not, might be something else. And if I look around the board, I don't see any other 3-4 pins connected to each other. I will also try to remove this heat shield. Maybe there's something more underneath that, and I will take this out of case. And yeah, I don't want to damage it, so I will just remove this tape and remove this cover and the cable. Okay, so you know what? Let's go under the microscope and take a look at all these boards there. I will be right back. Okay, so we are going to take a look at these boards now under a microscope. The first one is actually, this is the TP-Link one, right? The 300 megabit per second TP-Link one. So as you can see under the microscope, here. These are the 4 pins that I was talking about. And these are potentially UART. If you're trying to look for a UART port, you basically need something like this, like 3, 4, 5 pins in row, usually always almost 4, but there might be some, just throw you off, to throw you off. So I was looking at it and now I just noticed this. This looks like not connected. So if I do a continuity test, let me see. Let me bring my multimeter. So first, let's see if I touch, you can hopefully hear it in the microphone. So if I touch from inside this pin to here, there is continuity, but here there is not. So possibly, yeah, there is no continuity. So possibly they have done this to prevent UART to work as is. So we are going to try to repair that and connect these two together. So that's just one of the measures companies countermeasure they do in order to prevent people from just connecting to UART and reading the logs and sometimes even getting shell. And as we are looking further, there are like 2 chips that I want to ICs that I want to show you. So one is this one, AH1526. Basically we need mainly this one. I have to take a photo of these under microscope so I can later use those. Okay, I took a photo of this one. So this is most likely the flash chip that I was talking about. We are going to try to use the reader to try to dump the contents of this. And there is one more in here. Doesn't look like one, but I'm going to take a photo of it anyway, and then I'm going to take a look at it. If it is a flash chip, we are going to read that as well. And there is nothing else. These are the processors and all that. So there is nothing else, and it's still in the case because the antenna is soldered here. So I didn't want to damage it. I want to actually play around with it still after this video. So yeah, this is why it's still in the case. So that was the first one that I checked, right? The second one is actually, I wrote it down. So Linksys SE1500. So this is a unmanaged switch, and I don't know if when I was at the table there was like covers on this. So let me take these away. So that was like a heat spreader, heat sink, whatever they call it. And yeah, this is Theros processors for routing stuff. So this is as well. That's probably like Ethernet chip. Oh, this is glued or something. Yeah, but we don't have anything to do with this, so I'm gonna leave it. What we are looking for are the SPI flash and UART stuff. And as you can see, I can see again 1, 2, 3, 4 pins together, and these might be used for UART, but I might be wrong. And then when we look further down the board, I can see there is one in here. Let me see if it needs alcohol, and I see there is some markings on it. Okay, yep, that's good enough. So I'm going to take a photo of this as well. And if we look further, there is one more that I suspect. I don't think this is SPI chip, but again, because I don't want to come back to the microscope, I'm just going to take photos. Yeah, so that's also possibly a flash chip, but I'm kind of sure this is a flash chip. So that's what you need to do basically. You need to identify flash chips like this, ICs like this, and then later read what's written on it, and hopefully you can read it and it's visible. So you configure your programmer, you modify the chip and specify what is it written here, and then try to read it. And hopefully it will contain the firmware. This is same across the board for many devices. And as you saw that I did it also with that Chinese motherboard, very modern, that was just released, and you can still do that. And that's also one of the ways that you can repair motherboards with a like bad BIOS, right? So you read and write with that programmer. And this one,
I can see that there's one in here that could be potentially a flash, and there is another one in here. So I'm going to take a photo, and there's one more in here. Let me see. No, I don't think so, but as I said, I don't want to come back to microscope, so I'm going to take photo of all these, and then we are going to go over to the laptop and try to read these. Okay, got that. And the last one is this one. Okay, so yeah, we identified potential flash chips that way, right? You have to identify the flash chips, and then you have to look for potential JTAG or UART ports, and then we are going to try to read that in the computer. So this one is also, I'm taking a photo. Okay, all right, let's go back to the computer and see what we can do with these. So we are going to take a look at these boards under microscope. The first one I am going to take a look at it is this TP-Link one. So let me see if I can show you. Yeah, so TP-Link 300, the TL one, right? So let me flip it over. And as we are looking at the board and going around, right? So you can see that this is the port that I was talking about that looks like possible point for UART, right? So we can see there is 4, and this could be ground, and these are potentially one is RX, TX, and VCC. So we'll see their order, and sometimes I can already see something going on in here. It looks like this is not connected. You see that I was talking about that sometimes.
Okay, so we are back and we took a look at everything under the microscope. So what we are going to do is, let's do one UART and maybe a couple SPI flash chips and see how it is done. So in order to do that, first we had to identify the ground pin, right, in this UART. So that's relatively easy. All you have to do is put your multimeter in continuity mode and find a ground and see if the first pin is ground. It's not, and you can see that the second pin is the ground pin. So we already know the ground pin, and in order to connect this to your UART adapter, that whatever you're using, so in this case I'm using this device, right? I'm using the 3.3 volt version because this is 3.3 volt. So I am just going to plug that, and I only need 3 cables, RX, TX, and the black. And I will show you when we go to the laptop, I will show you how do I know which is which. So let me plug those cables first. So yeah, something like this. So I connected the 3. The top one is VCC, so we leave that alone. And I connected the 9 volt power, and yeah. So now let's go take a look at it on the computer. So first thing we do is open up a terminal, and before that let me just quickly show you how did I know. So as you can see, this is the device I am using, so your device might be different, so you have to look what TX and RX pinouts are in your cable, and these are the ones, red, orange, yellow. So what I needed was the orange and yellow, TX and RX, and the ground, which is black. So that's exactly how I know which cables to connect. The rest we are not going to use. These can be used for other protocols, not needed for UART. And also I have this open in this tab, which is, I just searched UART baud rate. So you need to know the baud rate of your board in order to be able to read that. Imagine that's something like a sampling rate, right? So we are going to do brute force, basically. We are going to brute force and to figure out what baud rate is for this board. I always start in the middle, and one thing I noticed actually is this one. This is incorrect. It's actually 115,200. 200. So whoever is running this web page, that is invalid, or maybe Google cached it differently. So it should be 115.200. So what you have to do is, I personally just use screen, but you can use anything you want. So let me just drop to the root shell. Sometimes I forget sudo, so it's easier to do it this way. And then I do screen. And before that, you need to know that your device is always something like this: TTY USB 0 in this case. This is again Ubuntu/Linux version. If you want to do it in Windows, that's going to be COM ports, and you need to install a driver. So we'll come to that. So we check, and yes, our device is there. So what we do is we just say screen and TTY USB 0, and if we can start with 9600, right? We start with the 9600 and we run it. As we are waiting for that, now I am going to power on the board. Okay, you see that's all gibberish. I'm going to turn it off. This tells you that this is an invalid baud rate. So you just press Control A and D and exit the screen. And then let's change that to 115.200, which is most common in these boards, right? So let's go with that baud rate and run again. That's running. Now let's turn it on. There you go. Now you can see that it's a clear text, and we actually got a UART access to this device. And one thing is that some of these devices might automatically just drop to the shell and do not even ask for a password. Sometimes they ask for a password. In any case, sometimes they have a backdoor password. So in any case, in order to figure out that part, in order to figure out the backdoor password or the hidden password or the password, you might need to be able to read the flash chip and maybe analyze the binaries, analyze the firmware to figure it out. But in this case, we just want to see if it drops to a prompt. And I know a backdoor password. I googled it, a backdoor password, or let's not say backdoor password. It's just a static password set in these devices that we can use in order to access it. So as you can see, it's it's asking for a login. So I believe the username and password is admin, and the password is I believe Soho admin, something like that. Let's see if I got that right. Admin, Soho admin. Was it? No. So root, maybe it was root. Let's try again. Okay, so that was it. So root and Soho admin was the username and password to drop to the shell. And we are root, and I don't know if there is a ID, but yeah, it's okay. So this is basically a way to get a shell in this device, and so we kind of cheated, right? We got the username and password from the internet. Now we are going to see what could have happened if we didn't know the password and we wanted to try to figure it out on our own. So that's where the reading of the flash chip comes into play. So before doing that, I can also do a very quick UART on this other device that I honestly don't even remember where I took it out of. I don't know what this device's purpose is, but let's do that quickly. Let's turn this off, take it out, and take these cables out. So what I'm going to do is, this one actually, they were very kind. They have the labels, so ground, TX, and RX. So let's connect them accordingly. All right, so I have connected, right? And this one is actually powered by a micro USB. So let me grab a micro USB cable hanging over there. Okay, before we have to, remember, we have to start the shell again, the screen, sorry. And let's connect this. Okay, so I just connected the micro USB cable and connected the UART cables, and now take a look at the computer. This one actually, I figured it out. The baud rate is 57,600. So let's run that and turn the board on. And as you can see, this one as well starts to spit out the UART data, right? So make sure your cables are not touching. Yeah, it's not. I did a quick job. The soldering wasn't really perfect, but let's see. Let's do it again. Okay, yeah. So the screen sometimes act up and I switch to Minicom, and yeah, this is much better. So as you can see, this is also booting, and this is also a UART on a different board, and that's also working, which I honestly don't know what is going on in this board. We'll figure it out later. So that's basically a long story short for reading UART connection from different boards, right? And that's the methodology. You just need a UART cable that is capable of providing, you know, the connection to your laptop. There are various adapters for it. And let me take this out. Yeah, and identifying the pins, identifying the UART pins, and just connecting the correct pins to correct cables, and that's pretty much it. And running a screen or Minicom or similar tool. So that being said, let's try to read the flash chip and the contents of the firmware of this device. In order to do that, what we are going to need is going to be this programmer, right? So we have this programmer, and there is another one that I have too, right? So we will be able to do that easily with any of them, where both should work. I created this one myself with the cables. There are like pre-made ones as like this. I like this one more because I think the clip, this one grasps better and the connections are made easier. But yeah, we can do with basically with any of these programmers. So let's try maybe first with this one. Hopefully it will work. If not, I'm gonna switch to that. So what you need to know is that the red one is always pin 1, and that's connected here as well to pin number 1. Let me see if you can see it on the camera. Yeah, so red to pin 1. So it basically goes 1, 2, 3, 4, 5, 6, 7, 8. And same thing on the chip itself. You need to identify the orientation by finding this circle, the small dot that's on the corner, one corner of the chip. In this case, it's on the top right corner. So we are going to leave this one this way, connect the chip this way. So pin number 1 matching the pin number 1. Okay, we'll connect that later. So first let's do this because we're gonna keep moving the cable. And on this one, you have to open up the connector, place the pins inside. So this one is a little bit tricky. Let's see, seems like all the pins. Just inspect after inserting, inspect, make sure that they are all the way in. Connect your programmer to your laptop and then run your programmer's software. In this case, I'm using the programmer that came with this. Let's connect it. Okay, first, before that, I have to also read the writings on the chip, and I took a photo of it, so I just have to type it out in the programmer. So this is the chip, 25Q, so let me type that, 25Q32CSC, and it's a Giga device, and I am going to choose the SOP8. So that's the chip, and now I will connect and the orientation, make sure that you get the orientation right. Okay, I am going to be, it's a little bit tricky as you can see. Yeah, I don't think it is connected, so let's try again. Okay, let me switch this one. Okay, as you can see now, I'm in a very awkward position, but yeah, this is the only way that I could get it to work. Basically, the other one did not work properly. So I'm using the Flash ROM program, and you can just install it with apt install Flash ROM. And I connected the pins, I'm holding onto it. I just want to make sure that it is reading it correctly. And I'm using the CH341 adapter in this case. And this is the cable that I just put together. But as I said, the clip is much better, stronger, and makes better connection with this blue one, which I think you can't see much on the camera, but yeah, this is the situation. Okay, I was able to read it, and it is read properly and successfully. Now let's take this out. That was the chip number 1, right? So we read the flash memory on this one and called it data.bin for this one, and let's do that for this as well. And I can see that this is the chip And let me read this again under microscope, take a photo, and I'll be right back. Okay, so this is the chip, and I took the photo, and let's connect this. I am going to insert this back in USB port. I'm going to prepare the command. So let's call this data 2. I know that's not a proper naming, but yeah, I will just temporarily do that. And yeah, the pin is here. That's the first one. Okay, so orientation going to be this way. Okay, now it's connected. Okay, so this one is actually asking for the exact definition, exact chip. So this one is, as we took the photo, so this is 25L640. Okay, let me type that out. Okay, so we specified the model of the chip. In this case, it was the MX25L6406E. And now the flash ROM is able to read the contents of this flash memory. And in different way to do this, sometimes, you know, the flash chip is so close to another big component like this, right? So you're not able to actually clip anything to it. What you need to do is you can desolder that part and then take one of these boards and solder it in here and then try to read it, right? You can see it here. Yeah, you can solder it in here and then try to read it by connecting it basically like this, right? So you need to insert and solder these joints so you can insert it into the programmer. So that's another way. And the reading of the chip is done, as you can see on the screen. So we read the first board and the second board. So let me put these aside. So long story short, what we did was we were able to get a UART and get shell. We cheated, we found the password online, but we are going to also check the flash memory and see if we can figure it out on our own. And then on this device as well, I'm going to remove this. So we were able to get UART and we were able to read the flash memory on this device as well. So the next step is going to be logically analyzing what we just extracted from both devices. So let's go back to the computer, right? Let me actually ring the keyboard and mouse. It's much easier this way, right? We're done here for now. So let's go to this here, as you can see on the screen. So let me make a folder and then move the two .bins in here. Okay, so we got data and data2.bin. So data is this white one, right? This one, and which is the TP-Link TLWR841N. And this one, unidentified board, mystery board that I don't even know what it is. So what you can do is, first of all, let's check the size. And they are, one is 8 megabyte, the other is 4. So what you can do is just say binwalk-e for, and you can always run it without any commands and get the help, but binwalk-e for extract, and then we can extract the data.bin. And as you can see, it was able to, let me make this bigger, it was able to identify that, find the U-boot string and identify the version and build date and time and some other file system and files. Same thing, let's do the same thing with the other one, 2.bin, and the same thing with the second one. So we were able to, now let's check those files, and if we go to the flash ROMs folder and yeah, let's do one thing. Okay, so those are bin ones, those are owned by root. So data.bin, right? These are the files that are extracted, and squashfs also got extracted, and you will see that there are various binaries that was on the flash chip, and these are the applications basically running on these devices. And by loading these apps on the reverse engineering tool like IDA or Ghidra, you should be able to reveal a lot of secrets and vulnerabilities in these apps. And by identifying the application responsible for running the web interface, you might be able to find some backdoor passwords for the web interface, web admin panel of these boards, and so on. So this is just an example, and same thing with the other one, right? Yeah. So same thing. Yep. There you go. Yes. this one has more files. So that is going to be this one. This one had 8 megabytes and took longer to read, and this one had a 4 megabyte and it was faster. So that's the gist of it, right? Being able to identify UART ports and seeing that and soldering the pin headers, and then same thing in here, right? This one came off. So soldering the cables for UART, and then using a programmer to program to read the flash chips, or using a cable like this to read the UART data, right? So these things are called SOIC clips, right? As I said, I think the blue ones have a better edge and makes a better connection and stays better on the chip. That's just the personal opinion, but yeah, they usually don't come with wires like this, like pre-soldered wires. So you might have to do that yourself, but all you need is a programmer SOIC clip, 8-pin, and also a cable like this to be able to access UART and read the data, read the console, read the UART. So tools wise, that's all you need. And on the software side, you can use Minicom, you can use Screen. In Windows, you can use Putty, however they pronounce it. So you will be able to use these programs to read the contents communicate over UART with the chip, with the board, and with the programmer, you will be able to read the flash memories. So yeah, that was mainly it. So let me know if you want me to do a full-blown reverse engineering on one of these boards, and show you how you will be able to reverse engineer the binaries after extracting them. That's a totally different topic. It doesn't involve any hardware, it's just all software. You just do the reverse engineering. In this video, I just wanted to cover the ways that you can use to communicate with devices and read the contents and hopefully reveal secrets and vulnerabilities afterwards in the software side. So that should be it for this video. Let me know what you think. What should I do next? If you want me to show you the reverse engineering side, I would be more than happy to do that as well. Okay, I don't want to make this video any longer. We covered what I wanted to show you, I believe. Okay, so that was it, and thanks for watching. Sorry, before I go, one last thing I just remembered. I didn't show you where you can find that Soho admin password thing, right? I forgot to do that completely, sorry. So very quickly, I will show you that. So that Soho root and Soho admin was found on this one, right? I Googled it, I found it, but let's say you don't know how to find it. Now you want to find it. So this is the extracted folder, right? And once you go in here, one of the first things that you can check if there's any hard-coded passwords, right? So in order to do that, you can go to etc and shadow file, and you will see that indeed there is one hard-coded credential, root, and a hashed password. So you can obviously try with Hashcat and crack this, but one of the first things you can do is, again, just Google it. And okay, not like that, but you go to google.com and Google it, and if you go to this website, you will be able to see that someone else ran it with Hashcat and specified the parameters, and then it was able to find the password, which is Soho admin. So that is how others found this backdoor password that you can use in order to get a root shell on this board via the UART connection. So yeah, just wanted to add it in there very quickly. Sorry about that, and thank you again. We'll see you on the next video. Bye for now.